Okay, I forgot to hit the record button. So we get into a position where we need time and we do not have it. We can start with this. So here we're tying together displacement, time, and your initial and final velocity. We can make this a little bit easier. We can kind of rationalize it by multiplying everything by 2 and getting rid of that half. So we get 2 delta x equals vi plus vf delta t. Okay. We can now solve this one for time. That's right, this is the other workaround. So if we divide 2 delta x by vi vf, we now have an equation that plugs in for delta t. Okay. Well, we have this. Average acceleration times delta t plus vi. Actually, let me reverse that. Hold on. Cut. Vf equals vi plus a delta t. We can now take this. Oh yeah, this is a much more elegant rearrangement. I forgot. And we can do the following. Vf equals vi plus a times the quantity, 2 delta x, over vi plus vf. Okay. So at this point, let me pause while I rearrange. At this point, we can start to do, so, moving stuff through the parentheses, just doing fairly simple rearrangement, divided by vi plus vf. We can multiply both sides by vi plus vf to rationalize. Vf times vi plus vf equals vi times vi plus vf plus 2a delta x. We can then, let's see, oops, misstep. What we end up with is vf squared equals vi squared plus 2a delta x. So the algebra of getting there is a little bit ugly. It's not as ugly as the one that I did. I forgot about this one. It's simpler. This is the the third of your 4 goldens. Okay, vf squared equals vi squared plus 2a delta x. We're going to look at sample problem 2e on page 57 together. Pushing a stroller from rest, and I'm just going to do this. So we have this stroller. It has some initial velocity, and we have a rate of acceleration. We also, what we want is a final velocity after some time interval. So at, we want final velocity after a distance interval. Okay, so we want to know how fast it's going at the end of 4.75 meters. So we list our variables, vi, vf, a, delta x. And this is another one where we do not have time, but we want to find a final velocity. So our vi is what? 0. Yeah. Vf is what we're looking for. What's our rate of acceleration? Yeah, 0.500 meters per second squared. And our delta x is 4.75 meters. Okay, the equation that we just derived, vf squared equals v, let's shrink this. Move that up. Equals vi squared plus 2a delta x. That we don't even have to rearrange. All we have to do is take a square root. So vf equals square root of vi squared plus 2a delta x. Okay, this one's pretty plug and play. Well, vi squared is 0, So really what we're doing is the square root of 2a delta x. Okay, you got a raw answer? Okay, what's our raw answer? $2.17 944 9470 2 meters per second. And of course here we had meters per second squared times meters gives us meters squared over second squared. We took the square root. Our units are meters per second. How many sig figs can we have? 3. I think I put in an extra 0 on our acceleration. So we can have 3 sig figs. We're going to there. So final velocity at the end of that distance interval is 2.18 meters per second. Okay. Your book, this is on page 58, there's a cheat sheet of these 4. They split it up into things where VF is 0. I think you're smart enough to do this. Knock out VI when it's 0, or knock out VF when it's 0. The only note card that I use for all of the physics we're going to do has this on it. And then it has delta x equals 1/2 VI plus VF delta t. It has VF equals VI plus A delta t. It has delta x equals, this is my personal favorite, I don't know why, VI delta t plus 1/2 A delta t squared. And it has VF squared equals VI squared plus 2A delta x. That's all I have on my note card. When we start doing especially motion on 2 dimensions, we're going to derive a whole bunch of things that come out of these, where you're combining x's and y's and you're combining the 2 axes. I don't put any of that on my card. Reason being my experience in college physics of having a bunch of equations and not being positive of when to use them. If you go back to the basics, if you go back to these 4 equations and you look at, you know, what does this tie together? What does this tie together? What does this tie together? You can't go wrong. If you list your 4 variables, or more later, and you look at what is tied together with an equation, you can build all the derivations. It will also strengthen your algebra tremendously. So, page 58. Did I already write that up there? 1, 2, 5, and 6? Okay. I will on Monday. So here's what's going to happen on Monday. You'll have a FIP quiz on using the 4 golden equations. So I would suggest that you get a really good chunk of that homework done so that you're comfortable using all 4 equations. I'll assign some additional problems from the chapter review, and I may give you a few problems. So this textbook provides for each section of problems. So you're noticing like there's a practice 2A, then there's a sample 2A. Well, there's also, oh, and I have to figure out how I'm going to access that because it's on a CD. I'll be printing those at home. And on the CD drives. There is additional problems, 2A, additional problems, and the additionals tend to be a little bit more challenging. So they're good practice. Okay, have a wonderful day. Zach. Yes.
Make sure I got this. Yeah.
Yeah, you said go online and do it. Yeah.
Can I take your calculator too or no?
Yeah, you know what? I should have calculator signed up too, huh?
Have a nice weekend.
You too. Looking back on it, it wasn't a wise decision. Have a good weekend. Enjoy the dance.
Where do you do that?
I'm going to a concert instead.
Oh, okay.
Yeah, I've been an
On
idea.
this front, oh, it's on the front page. So go all the way back to the front page.
We were talking about that in Solid Writing, Zombieland movie.
Is this the one with Brad Pitt? No, that was Zero or something.
Yeah.
World War Z.
Or something. Student books, I know.
I never actually watched that one.
I haven't.
I
The
watched
only
some of
zombie
it.
movie I have seen, hey Connor, is Shaun of the Dead.
That is
Love
wonderful.
Shaun of the Dead. Yes, ma'am.
I wanted to ask the same question I asked yesterday about the quiz, because I took that one and awesome too.
Oh, no, same deal.
Thank you.
Should I go show this to Ms.?
Yes, and you want to pass?
Yes, please.
I'm gonna sit here and read, I'm gonna do tests, I have to get them done, but then you can watch the video and then start on the work. Zach, and you're no H, right?
So actually, no.
It's your name, okay, sorry. My mom's birthday was Wednesday, I know today's date. I've been working off of Wednesday's date all week.
What's today's?
25th. Do you need to sit and work? Okay. I'm gonna sit here and grade chemistry tests. Zach is also gonna be working, and then I can pop in and out and work with you guys. And you know what? I'm gonna move this thing because it doesn't work the way I had hoped it to. So I really want, and if it's, I see how Mrs. Motry is using this as a student aid desk. So I'm gonna put it, and that's, I was like, why is he sitting there? That's kind of weird. That was like my little lecture podium, but I see what you were sitting there. So we're gonna put this in the back.
Yeah, because I saw first students doing that, and I was like, ah.
Yeah,
I wonder if most of us will never do
and that wasn't my plan, but you know what? We can sit it here. Why don't you grab the chair? No, actually, I really like that chair for like a high, like a lecture desk for me, or a lecture seat if I ever get to sit down. I will take it back there. I'll steal another one.
Then I can take the calculator.
Yep,
All right, thank you.
no problem. Happy travels, sir. Have a good weekend.
You too.
Good luck tonight. Don't get injured.
Oh, I can't play.
Oh, good. Not good, but if
Good for your health, bad for the game.
yes, I'm happy to have a child for whom it's not going to be an issue of like, is she going to play football or not? Because I would be really nervous. So, hey, have fun tonight. Huh? Yeah, it's hard. It's hard on the body. Oh, good Lord, this is still recording.